This is another edition of Going Beyond Testing. I'm Mark Alyn. We are spending some time with the CEO of NJ Labs, and that's Sandra Lee. Sandra, let's talk about heavy metal testing. This has really been in the news lately. People are ingesting supplements, nutraceuticals, even foods,
right,
and they're being tested with heavy metals, which would be, I guess, lead, mercury, maybe others.
Cadmium, arsenic. So heavy metals is ubiquitous, right? It's everywhere. It's in our food, like you said. It's in everything in our environment. A lot of pharmaceutical products, dietary supplements, nutraceuticals, foods, they're all coming from somewhere, which is either plants or other roots or things like that. So when manufacturing is using these ingredients, they should be testing for heavy metals, especially in plants where some plants like cannabis will extract the heavy metals out of the soil, and it kind of cleans the soil, but now we're using these plants for other things. So heavy metal testing is very critical because if we consume too much of it, it starts to build up in our body, right? And it could have long-term effects in the future.
And I know you're not a doctor, but heavy metals can cause mental issues and others. I just remember buying a can of tuna, and it said, "We test for heavy metals," which is, I like that, and I bought that, right?
I haven't seen that, but there are different types of methods apply for foods. There are methods apply for cosmetics, depending on the industry, right? But no matter what method you use, it's really important to make sure, again, the word verification comes through, making sure that the method actually measures the things that you're looking for. For example, arsenic, cadmium, mercury, or lead, right? So we use this special instrumentation called ICPMS. It's the same instrument that the FDA also likes to use. Fortunately, it kind of helps us align guidelines, and it helps us to meet the standard requirements.
Do other labs use the same testing method?
There's other methods. There's a lot of different types of instrumentation. What we like to do, and what we've done in the last several years with the ICPMS, was we develop a lot of methods. It's fairly new technology in terms of what United States Pharmacopoeia uses, right? They used to use wet chemistry, which is very manual. It's driven by people. It's not instrument related. You're digesting the metals on hot plate and adding acid. And then it moved to something else called flame AA, atomic absorption, right, which is very rudimentary as well. And then it has progressed to ICP-OES, ICPMS, and there's multiple different types of ICPMS. Very sensitive instrumentation, very expensive, and it takes a lot of expertise. It's not enough for you to use it every day for a year or two. We have chemists who have been using it for over 6-7 years, still be learning through the process. And what we found out is that samples have a lot of heavy metals, botanicals, supplements, even pharmaceuticals can have heavy metals during the manufacturing process, right? A lot of the machinery is made out of metal, steel, whatever it is, right? And metals can leach. It happens. It's not just a perfect environment where you put in samples, it mixes it, prepares it, and then you're okay, you're done. Right. But metals can be introduced at many different points.
And you have to, it's constant testing is what's needed to provide a safe product for the end user, and we're all end users.
Yes.
I'm thinking of peanut butter, and this is completely spontaneous. I don't know how Sandra's going to react to this. Peanut butter has a level of rat feces that are allowed in peanut butter. And what I've been told is that almost all peanut butters have a certain amount of rat feces. Would that be an analogy to the amount of heavy metals that are allowed in supplements or
Yes.
pharmaceuticals?
Yes. So different laboratories use different methods. Some methods are a lot more sensitive than others. For such things as peanut butter, a lot of laboratories use methods called AOAC. AOAC is not known for used in pharmaceutical testing because of the different levels of detection, sensitivity, accuracy, and precision, right? So a lot of times the foods that are being tested, especially if there's rat feces, it's like bacterial microbiology testing, which we also do here. And what we found out is when you're doing any type of testing, you want to be able to know that it's specific to what you're looking for. And we can do that by spiking your sample with that pathogen or that bacteria, or in particular in this scenario, is it E. coli or salmonella. You can spike it with this pathogen. You got to recover at a certain level to show that that method is appropriate to test peanut butter, right?
Wow. One of the things that this brings up is, we've talked about this before, is auditing your contract third-party lab. Mm-hmm. This would be very important if you're doing, I would think, peanut butter. Yeah. You know, Mark Allen's peanut butter. I don't think so. But if you're doing something like a nutraceutical, we're going to be talking about cannabis and CBD in another episode. All of these for heavy metals, this should be an ongoing process.
Yes, so manufacturers should always ask the laboratory, what method are you going to use on my product? How can I trust your results, right? So we have to test out that method on your product to make sure it is appropriate. Because, for example, a lot of the food products that we eat, or even supplements and pharmaceuticals, have preservatives, right? Either natural or synthetic. And these preservatives their job is to kill the bacteria, so you're not going to get sick from eating it, right? But the problem is, a lot of these laboratories, what we've experienced is, if you just use a generic method, you're not neutralizing that preservative. What if later on down the road, the effectiveness of the preservative decreases? Then whatever pathogen is in your product has room to grow. So it's important to work out a method neutralizing that preservative for micro-testing and spiking it with the pathogen to recover. You have to recover a certain amount. There's specifications to meet. And then you work out that method that way, it becomes validated, right? Now that method is appropriate to test your product because you're not going to get false negatives or false positives in the future.
And as we've mentioned before, the validation is so important for the manufacturer, the person who owns the formulation, the product, and any other third parties that are involved in the development and the processing of those products.
Yes, and manufacturers should always ask questions. Questions, because the more answers you have, the better equipped you are, and you can produce better quality product, and you can save money in recalls or people getting sick down the road and having to figure out these problems after the fact. It's better to prevent it from happening.
One of the things that just popped into my mind is the quality control.
Yes.
So you use initials, QMS. Mm-hmm. What does that stand for?
Quality Management System. That's very important because that's the foundation of the company. It's the foundation of our company, and it should be for many other companies. And those are procedures to make sure that you have all the right equipment, appropriate equipment. You have the right training, the right staff. You purchase the right equipment and supplies and reagents and standards. So at that very end, what you are getting are results, right? You want to make sure your results are unique to your product, that it's accurate, it's rugged enough that even if there's mild changes, it still continues to be accurate, right? So QMS is like building a house. It's like a foundation where you pour concrete and you build your house upon that. If that's weak, everything else will crumble. And that allows us to integrate different departments. So you have, it's like cogs on a wheel. You can integrate different departments. If you have a good QMS, it should flow very well. And anytime there's issues, like something fails or there's an investigation, there's a process to follow, and that you're not leaving anything unturned.
And in the concrete example that you used, a contractor might use what's standard, okay, what the building code calls for.
Yes.
Or they might use something that's even better than code.
Yes.
Or subcode. That's what you're talking about,
right.
Really.
It's the same application in a laboratory. You can use the standard materials that's available, or you can have higher quality by purchasing better equipment, better supplies, having even a trained staff, right? You can have minimally trained staff, and you can have very well-trained staff, and then that makes all the difference in the world.
And the staff here at NJ Labs?
Very highly trained.
Thank you, Sandra. Listen, if you would like information about NJ Labs, we have a website that you can visit. And we also invite you to come to New Jersey and visit here, because you can see exactly what Sandra and her staff are doing. Just check out the website that's on the screen now. I'm Mark Alyn for Sandra. We'll see you on our next episode.